Okay. Okay, enough of the balloons.
You make such fun noises.
I know, but it'll mess up Caitlin's video.
I made the
Okay.
ears. It's a ray gun.
You got that I did 31, right?
Yes.
And 33?
Yep.
Okay.
I did.
Shut up.
Okay, so tangent and cotangent are very similar to what we've already done. We're going to use the same strategy, so it should be pretty familiar. So this is going to be y equals a tangent of bx minus c plus d. So if you look over there, it's very ugly, but the middle one is your regular tangent of x graph right here. So we can see that it goes like that. And then 1/2 the tangent of x. Remember we talked about those critical points on the tangent graph? So when we change the amplitude, it's not really the amplitude because there's no max or min, but we're just raising or lowering this point where the graph starts to turn. So we're either squishing it down closer to the x-axis or we're pulling it up farther away from the x-axis. Okay, so that gives us sort of our critical point setup for the tangent. So we'll review that before we go to the tangent. Okay. So what was different? Do you remember what's different about the period of the tangent compared to the sine and the cosine?
It's a
It's the asymptote.
Yes, do you remember how big it is?
Pi.
Pi. So instead of 2 pi, the tangent has a shorter period. It's only pi. And instead of starting at 0 and going on the positive x-axis for our normal graph, the graph is centered at 0, 0. So you can see that from the graph up there, that it's actually centered at 0, 0. So for the tangent, the regular period is pi, okay? So that makes our period for anything pi over b. So any tangent graph is going to have the period of pi over b. Okay. So in the tangent graph, the parent graph, like plain tangent of x, there's an asymptote at negative pi halves and at positive pi halves. Okay? In every other version of this, you're going to have asymptotes at half of the period. So at plus or minus half of the period. Because we're centered over 0 for the tangent graph. So at positive half of the period and at negative half of the period, you're going to have asymptotes. Okay? So then, your points, your critical points. Okay? So on the regular parent graph, 0, 0 is a critical point. Pi over 4 and 1 is a critical point. And negative pi over 4, negative 1 is a critical point. So there's only 3 on the tangent graph, but you also have your asymptotes to deal with. So those critical points are those little turning points of the graph. Okay? So then if we look at generalizing those points, just like we did for everything else. Okay. If we have no shift or anything, right? 0, 0 is not going to change. And then we want to take whatever the period is, divide it into fourths, just like we did for everything else. So the period divided by 4 is going to have a maximum, which is not really a maximum, but it's going to be your positive a value. So that's over here, where you take that period, divide it by 4, and then you change it from 1 to whatever the A value is. And then if that is the case, then you're gonna have negative of the period divided by 4 and a negative A value. So those are your critical points if we're just changing the period and the amplitude. So this is a period and amplitude change. And I'm still gonna call it amplitude even though it's not. Right? Okay, so now we have to think about like what happens when we have a vertical and a horizontal shift. Okay. If we have a horizontal shift, not only do our critical points change, but what else is going to change?
All of the period?
Your asymptote is going to change. If you've got a horizontal shift, your asymptotes are going to, because that whole graph is just moved over. Okay, so, and our phase change, or a phase shift, is still C over B. So we would have to add C over B to our asymptotes. Okay, so you have a positive asymptote and you add the phase shift to it. You have the negative asymptote and you add the phase shift to it. Okay, because we're moving the same direction. Those asymptotes, both of them the same direction. Okay, so then here, if we have everything, we're gonna have 0, 0, but we're gonna have 0 plus the phase shift. And if we happen to have a D value, we're gonna have 0 plus the D value for our Y. Because if we've moved to the right, we're gonna add the phase shift. If we've moved up, we're gonna add the D value. And the same thing happens here. Your period divided by 4 plus your phase shift and your amplitude plus your vertical shift. And the same here. Negative P over 4 plus your phase shift and negative A plus your vertical shift. Okay? So that's going to be tangent. So if we had, let's do one real quick. I don't remember if I graphed this one, but we can real quick. So if I have y equals 2 times the tangent of x over 2, right? So the first thing I need to do is find my period. So the period is pi over 1/2. So that is 2 pi. Okay. So I know, oh, this one I better do in the middle. So I have pi, let's do this, let's do pi halves and pi. Let's do negative pi halves, negative pi. And then my amplitude's gonna be 2, so I need to go up at least 2, and down at least 2. So now I can start to find my points, okay? So 0, 0, I don't have a phase shift or a vertical shift, so I don't need to do anything with 0, 0. I'm still gonna have 0, 0 as a point on this graph. So 0, 0. So then the period divided by 4, so 2 pi divided by 4 is gonna go with the positive amplitude. So that's gonna be pi halves and 2. And then my next critical point is negative period 2 pi divided by 4, negative 2. So that's negative pi halves -2 right here. My asymptotes are going to be at plus or minus the period divided by 2. So they're going to be plus or minus 2 pi divided by 2. So they're at plus or minus pi. So here are my asymptotes. Okay, and then I know that tangent goes like this. Okay, that's the ugliest. I can't draw the tangent. Like, I can't do it. But that's sort of what it looks like. Okay?